Hey guys, it's Wilson with WD Explains. This is just a short recap video of our last video on Q equals MC delta T, just to figure out Q equals ML and when to use it. So just to recap, we'll just do a short question, just a basic Q equals MC delta T question. So here we have 50 grams of water being heated from 2 degrees Celsius to 5 degrees Celsius, and the C value is 4.18 joule per gram degree Celsius. So we'll write down our variables. Our M equals 50 grams. Our C equals 4.18 joule per gram degree Celsius. 0.18, we'll write that better. And our delta T here equals 3 degrees Celsius. We'll write that in as Q equals 50 times 4.18 times 3. And our answer here will be 627 joules. So that's pretty easy. It's a simple question. So what happens, I'll just let you guys read this, or I'll read it to you. Let's use Q equals MC delta T to solve if 50 grams of ice was heated from -2 degrees Celsius to 5 degrees Celsius. And we'll keep in mind at the end of this question here that we have that the MP melting point of ice is 0 degrees Celsius. So we're crossing a phase change barrier here. So let's just solve this as if we were using Q equals MC delta T and see our answer, and we'll compare it later. So here we have our M of 50 grams. C equals 4.18. I know there's some other information in the question, but we'll look at it later. And our delta T equals 7 degrees Celsius. So here we'll plug it all in. Q equals 50 times 4.18 times 7. And Q equals 1,463 joules. Okay, we'll keep that in mind. So, how are we going to solve this question correctly? So let's use Q equals MC delta T and Q equals ML together. So how do we do that? So just for starting off, we can draw a little diagram. And this is the simplest version of a diagram like this. We have our SP, our starting point, our PC, our phase change, and our EP, or our ending point. So our starting point here is -2 degrees Celsius. Our phase change is 0 degrees Celsius. I forgot to write it, but that's okay. Our end point is 5 degrees Celsius. Okay. You might notice we have two different C values. So we're starting with ice. So our left value, because we're starting here and we're going this direction, this C value is going to be 2.09. This C value is after the phase change, so we must be using liquid water. So this section is going to be 4.18 for our C value. So when we're solving this, basically we have three things we have to solve. The first thing is this first section. The second thing is this point. And the third thing is this section. So I'll let you guys pause and think what formulas we're going to use where. Okay. So for one, we're going to just use Q equals MC delta T. We'll put our variables here. M equals 50 grams, and I'm not going to write that again. It'll be the same throughout the question. Our delta T equals only 2 degrees Celsius. And our C value here is 2.09 joule per gram degrees Celsius. So the Q equals 50 times 2 times 2.09. And this is going to equal 209 joules. So for 2, this is where things deviate from before. We're going to use Q equals ML. So our M is still 50, and our L here is right in the question. It's 334 joules per gram. So we have Q equals 50 times 334. And this is going to equal 16,700 joules. As you guys can see, that's a huge number compared to the other number we get. That's already 10 times larger. So this is a very significant calculation that if you don't include it, your number is basically useless. So our third section that we're going to solve here, our M is still 50 grams. However, we've transitioned into this section, so we now have to use a new C value. So our new C value is 4.18 joule per gram degrees Celsius. And our delta T here is from 0 to 5, so it's 5 degrees Celsius. So we have Q equals 50, so because it's still the same mass, times 4.18 times 5. And this is going to come out to 1,045 joules. So if we had 1 plus 2 plus 3 together, we're going to get a grand total of 17,954 joules. So remember, we needed our answer from earlier. So 1,463. This is way smaller than 17,954. So this is a huge difference. And that is a very big difference to miss on a question if you were not use Q equals ML. So I'll let you guys try. I'll let you guys pause and try this question on your own. Okay. So we'll start off with drawing a diagram. Once you get the hang of it, you don't have to, but starting, this is probably very useful for you. So we have our starting point, our phase change, and our ending point. We're going from negative 17 degrees Celsius to 0 degrees Celsius to 10 degrees Celsius. We have our C here of 2.09, and we have our C here of 4.18. So we have our section 1, 2, and 3. So we'll start with 1. Our M equals 43 grams, and it's going to stay the same, so I won't write it again. And our C is going to be 2.09 joule per gram degrees Celsius. And our delta T, so we're going from negative 17 to 0, so it's going to be 17 degrees Celsius. So we have Q equals 43 times 17 times 2.09. This is going to equal 1,528 joules. We have our 2. And our L here is still 334 joules per gram. So we have Q equals 43 times 334. This is going to equal 14,362 grams. Joules, sorry. 3. We have the same mass, still 43 grams. I'll write it again. Now we've transferred into the water section again. So our C is now back to 4.18 joule per gram degrees Celsius. So I'll write it, or our delta T, sorry, is also going to be 10 degrees because we're going from 0 to 10 degrees Celsius. So if Q equals 43 grams times 4.18 joule per gram degrees Celsius times 10 degrees Celsius. And this is going to come out to 1,797 joules. So if we add 1 plus 2 plus 3, we're going to get 17,687 joules. So again, that's our final answer. You can try and calculate it just using Q equals MC delta T if you want, just to see how small the answer would be compared to it. That's it for the learning part of this video. I hope you guys now have clarity on how to solve this type of question. I hope you guys have learned that. If you don't, drop a comment down below and I'll respond to it. Like and subscribe for weekly quiz videos and more tutorials to come. Thanks.